The simple random sample of size n equal to 49 is obtained from a population that is skewed right, with mean equal to 75 and standard deviation is 28. Part A is asking to describe sample distribution of X bar. So in this case, we have to see if do we have normal distribution. So we should have a normal distribution finding mean of X bar and standard deviation of X bar. So to be normal, we should either have population normally distributed or our sample size should be large enough. So if you had population normally distributed, the answer for this part will be yes. Or if your sample size was greater than or equal to 3, in that case you're going to say we have normal distribution. So in this case it says population is skewed right, but here we have n equal to 49, so we can use this one to say that this sample size is large, meaning that our answer for this part is yes. So it's yes because of having sample size equal to 49. Then finding mean of sample mean is equal to population mean, and that is given is equal to 75. Standard deviation of sample mean is equal to population standard deviation divided by square root of n. Population standard deviation is given as 28. Our sample size 49. So here we have 28 divided by 7. The answer is 4. Part B, it's asking to find probability when X bar is greater than 80.8. Here, in this case, we don't have Z. What is given is X bar. So first step, we have to convert X bar to Z. So finding Z, X bar is what we have here on this part, 80.8. Minus mean of sample mean is equal to 75 divided by standard deviation of sample mean. We already have the answer here from part A, but it's better to always write all steps. So here the answer is 1.45, and you enter these into calculator. It's better to use parentheses, numerator, denominator, to make sure the answer is correct. If not, you may have a wrong answer. So the answer here on this part is 1.45. Now finding probability. So probability when X bar is greater than 80.8. That is equal to probability when Z is greater than 1.45. We have to use normal CDF. Because of having greater than, first we have to enter our Z-score, comma. Here on this part, we try to enter positive infinite large number. So you can enter 1 exponent 99, or you can enter 1e99, or you can enter 9999. In all these three cases, you're going to have same answer. So for example, let's have, for this one, let's have 9999 instead of 1e99 or 1 exponent 99, comma 0, comma 1. So we have to use second bars, number 2, normal CDF, enter. So you entered 1.45, 1 exponent 99. So here, to enter this one, you have to use second, comma, to enter e or exponent. So enter, enter, enter. Here is the answer. Again, so I'm going to repeat all these steps. And now I'm going to enter, instead of 1 exponent 99, I will enter 1e99 and then 9999 to see that we have exactly the same answer. So second bar, normal CDF. So this part I have 1e, or for e I use second division. Enter, enter, enter. Here is our answer, same answer. Again, second bars, normal CDF. Now I entered 9999 because we're trying to have large number. Enter, enter, enter. Again, I have same answer. So in all these three cases, we had same answer. I will round our final answer to, for example, for decimal place. Here it doesn't say. So if in case you round it to 2 or 3 decimal places, that is fine. But I'm going to round to 4 decimal place. But we usually have even a table to find probabilities we have for decimal places. So it's 0.0735, the answer for this part. Part C, what is probability when X bar is less than or equal to 66? So everything is exactly the same. Here again we have X bar, we have to convert to Z-score first. So in this case, X bar is 66, and mean of sample mean, it is the same as what we had in part A and B is 75 divided by standard deviation of X bar is 28 over square root of 49. So entering these into TI-84 or any other calculator, here I used TI-84, and this is my answer. I use parentheses, numerator, denominator, and the answer is -2.25. Next step, find probability. So here we have to use normal CDF. This is probability when Z is less than or equal to -2.25. So we have to find area to the left of Z. So first we have to insert negative infinite. The same as what I did for part B. Here, for infinite, negative infinite, I can enter -1 E99. negative 1 exponent 99, or negative 9,999. Entering negative 9,999, comma, over z, negative 2.25, comma 0, comma 1. So we have to enter negative. To remind you, negative is not subtraction. Is when you have on your calculator what you have inside parentheses. So we have to enter negative 9,999, negative 2.25. Enter, enter, enter. And here is the answer. Running to 4 decimal places, 0.0122. So on calculator, this says negative sign. When you're trying to enter negative numbers, you have to use this one. So it's not this. That is subtraction. Part D, here we have to find probability when x bar is between 70.4 and 83.4. So here again, we have to convert to z-score first. Over x bar 1 is 70.4, what we have on left side, and x bar 2 is 83.4. So convert x bar 1 to z1 and x bar 2 to z2. So for z1 we have 70.4 minus 75 divided by standard deviation of sample mean is 4 from part A. So the answer for z1 is negative 1.15. The answer for z2 is positive 2.1. Now we have to find probability. So probability when x bar is between these two numbers, that is equal to probability when z is between z1 and z2. In this case, we're not going to use positive infinite or negative infinite. We only need to enter z1 and z2, then 0 and 1 for mean and standard deviation. So normal CDF, negative 1.15, comma 2.1, comma 0, comma 1. So here is what we have to enter into TI-84. Then enter, enter, enter. Here is our answer running to 4 decimal place. The answer is 0.8571. So for all of these, we used TI-84 to find the answer for probability, but we can also use tables to find the answer. But the point is, on tables, we only have 4 decimal places. And over Z on tables is 2 decimal place. But if you have more than 2 decimal place, you're not able to use tables. So it's better to learn how to use TI-84. Simple rounded sample of size n equal to 75 is obtained from a population whose size is 25,000 and whose population proportion with a specified characteristic is p equal to 0.6. We have to complete part A through C. Part A describes the sampling distribution of p hat. So we have to see if is this normal. We have to find mean of sample proportion and standard deviation of sample proportion. To see if this is normal, we have to use n times p times q, and that should be greater than or equal to 10. So here n is equal to 75 over sample size, p is given as 0.6, and q is 1 minus p, so it's 1 minus 0.6. And that is 0.4. So multiply all these numbers, that is equal to 18, and that is greater than 10. So we do have this requirement, and the answer for this part is yes, this is normal. Now finding u of p hat, that is equal to population proportion p, and that is given as 0.6. Then here we have standard deviation of sample proportion. It's square root of p, it's 0.6, times q, it is 0.4, divided by sample size is 75. So I'm running this one to 4 decimal place. The answer is 0.0566. So these are what we need to describe sample distribution. But if in case you wanted to know if this is independent, so if do we have independent sample values, we can use sample size less than or equal to 5% of population size. And here sample size and population size, both of these are given. So 75 should be less than or equal to 5% of 25,000. And 75 is less than or equal to 1,250, and that is correct. That means that we have independent sample values. Part B, what is probability of obtaining x equal to 51 or more individuals with the characteristic? You may not, sometimes you may not have this part given. Even if this one was not given, you can find what is your p hat, because here x is given, and on top we have our sample size 75. But here on this part we have this p hat greater than or equal to 0.68, and that is same as what I have here. P hat is equal to x over n. Our x is 51, n is 75. And the answer is 0.68, which is exactly the same as what is given on this part. So again, if this part was not given, this 0.68 we can find, because we have x, we have sample size on top. By using x divided by n, we can find p hat. And then finding probability when p hat is greater than equal to 0.68, because here it says obtaining x equal to 51 or more. That means greater than equal to. So first we have to convert p hat to z-score. Our p hat is 0.68 minus population proportion is 0.6 divided by square root of p times q divided by n. And here I'm running to decimal place, 1.41, because usually we have 2 decimal places for z-score, but in StatLab, if was not asking you to run, do not run this part before finding the final answer for probability, because here in this case part B, it's asking to find probability, is not asking for z-score. So sometimes it's asking for z-score and it's asking you to, for example, run 2 decimal or 3 decimal places. So in that case you can run, but here in this case it's asking for probability. So that is what your final answer is. Probability, running that one, if it was asking for 4 decimal place, you should only run the answer for probability. not the answer for z-score. So in StatLab, do not run until the end. But here I have 1.41. I'm going to use this one and then compare the answer with when we're not running z-score. So here is what we have for z-score without running. So here we have to find area to right of z, because we have z greater than or equal to 1.41. So first we have to enter our z-score. I run it to 2 decimal place. Here on this part it doesn't matter. Like on StatLab, you may have a wrong answer because of running z to the 2 decimal places. So I'm going to find the answer for this part first, and then we'll find the answer for when we're not running z and compare the 2 answers that we have. So for this part, our answer running to 4 decimal places, 0.0793. So this is our final answer for part B. So here on this part, I used normal CDF and I entered z without running. So entering z without running, comma, infinite, comma, 0, comma, 1. And then here we have z-score rounded to 2 decimal place. Comparing these 2 answers, running to 4 decimal place, when I rounded z-score to 2 decimal place, the answer was 0.0793, but without rounding z-score, running to 4 decimal place, the answer is 0.0786. So a slightly different answer. If we run to 3 decimal place, for both of these, we're going to have 0.079. Same answer, we're going to have same answer running to 3 decimal place, but 4 decimal place, we're going to have slightly different answer. So in that case, your answer on StatLab will be wrong. So it's better to not run until the end. Now part C. What is the probability of obtaining x equal to 42 or fewer individuals with the characteristic? That is, what is probability when p hat is less than or equal to 0.56? Here again, even if this 0.56 was not given, we are able to find p hat because x is equal to 42 and our sample size is given on top that was equal to 75. Even if this part was not given, finding p hat is x over n, 42 divided by 75, and that is 0.56. Now finding probability first, we have to convert p hat to z-score. So the same as part B, converting to z-score, we have p hat minus p divided by square root of p times q divided by n, and in this case p hat is 0.56. So the only difference between part B and C when we're trying to convert to z-score is over p hat, what is given here on this part. Here we have 0.56, and this is our answer for Z. This is what we have. If I run to decimal place, the answer will be negative 0.71. So we'll find the answer based on Z rounded to 2 decimal places, and also we'll find the answer for when Z is not rounded, and then we can compare our answer. So probability when Z is less than or equal to negative 0.71. We have to find area to the left of Z. So first we have to enter negative infinite, the number z-score, comma 0, comma 1. And here is my answer based on z that was rounded to 2 decimal place. So rounding over p to 4 decimal place, the answer is 0.2389. But right after that, when I try to enter z without rounding, and this is the answer, 0.2397 if we round to 4 decimal place. So slightly different answer. Even if we round to 3 decimal place, again, we're gonna have different answer. But rounding to 2 decimal place, we will have same answer for P. So we have different answer, and in that case, your answer on StatLab will be wrong because of rounding. So here I'm writing based on the z negative 0.71. The answer is 0.2389. But without rounding, this is our answer. So without rounding z, that is our answer, which is correct. But here I'm writing this one. So without rounding z, the answer for probability is 0.2400 or 0.24. Comparing the two answers that we have here, we have slightly different answer.